Hi guys, greetings of the day. I Vijay welcome you to my YouTube channel for learning a subject called Fluid Power Engineering for 5th semester and Fluid Power Systems for 7th semester as per VTU syllabus. If you haven't subscribed to my YouTube channel yet, kindly subscribe. Also click on bell icon to receive the latest lectures as and when it is uploaded in my YouTube channel. Now, let's start the session number 16. The session 16 is with respect to the accumulators. What is called as an accumulator? An accumulator is simply a container to store a potential energy of incompressible fluid and on demand make the energy available to the system. The energy is stored against a dynamic force which comes from either a gravity or a mechanical spring, or even it could be a compressed gas. The accumulator hold high pressure fluid for a long period without keeping the pump running. It eliminates pressure ripples and provides for leakage compensation and act as a source of hydraulic energy in case of power failure. Now figure shows the graphic symbolic representation of the accumulator. And coming to the classifications or the types of accumulator and their construction, which are as follows. The first one we call it as deadweight type of accumulator. Second one we call it as spring-loaded accumulator. And the last one we call it as HydroPneumatic type of accumulator. Now let us understand one by one. Now deadweight accumulator, you can see the figure on the left hand side. The deadweight type of accumulator is the oldest type of accumulator used. It consists of a ram R sliding in the cylinder C. The ram is loaded with the dead weight on its platform as shown in the figure. You can see it there. The fluid under the pressure from the pump enter the bottom of the cylinder via check valve and the pressure pushes the ram upward. The weight placed on the platform of the ram depends on the predetermined pressure it has to exert on the fluid entering the accumulator cylinder. The pressure exerted by the ram and the weight placed on it can be found by dividing the area of the ram contacting the fluid. Other type of deadweight accumulator is the inverted ram type, wherein the cylinder moves and the ram will be stationary. The force exerted on the fluid by the ram is relatively constant regardless of the position of the ram, and hence the fluid pressure in the cylinder is constant. The advantages of deadweight type of accumulator are being they supply oil at constant pressure throughout the full volume output and can serve as several hydraulic systems at a time. The disadvantages is because of their large size, they are not very popular and especially unstable for mobile equipments. And then coming to the spring-loaded accumulator, which you can see on the right hand side. This also contains a ram R moving in a cylinder C against a compressive spring. The accumulator uses the energy stored in the spring to create a constant force on the contained fluid. That is, the spring is the source of energy that acts against the ram, forcing the fluid into the hydraulic system. And these accumulators serve individual hydro systems and operate at low pressure. The pressure of the fluid depends on the compression rate of the spring. The spring pressure may be varied by adjustment. The force exerted depends on the spring stiffness, which is the force required to compress the spring by a unit length and is constant for a given spring. Our only disadvantage is they are smaller and mounting is easy. Sorry, it's not it's an advantage. And coming to the disadvantage, oil is supplied at low pressure. There will be a variation in pressure of the oil in the accumulator reaching a peak when the spring is compressed completely and drops to a minimum as the spring extends full length. And this typo cannot be used for high cycle rate applications as the spring will lose its elasticity due to fatigue. Then coming to the third type called as hydropneumatic accumulators, you can see the figure over that, the representation, the graphical, that is called as gas charged accumulator. The most commonly used accumulator in industries are hydropneumatic type. In this type, the force is applied to the oil using compressed gas. This works on the principle of Boyle's law of gases, which states that the constant temperature, the pressure of the gas varies inversely with its volume. The compressibility of gases is responsible for the storage of potential energy. Only dry nitrogen gas is used and air is never used because of danger of oil air vapor. And the hydropneumatic accumulators are of two basic types. The first one what we are going to discuss is called as the non-separator type, and the second one is called as separator type. Now let us understand what is called as non-separator type. You can see the figure. In this type of accumulator, there exists a direct physical contact between the gas and the oil. This type of accumulator are rarely used because of the formation of foam at the junction of oil and gas. And the non-separator type of accumulators are used in die casting machines and other similar applications. And these accumulators are always placed vertically. Then coming to the second type, that is called a separator type of accumulator. In separator type of accumulator, the oil and gas regions are separated by an element based on the type of element used to apply force on the oil due to compressed gas. And the different types of accumulators are as follows. We are going to discuss one by one. That is called as piston type of accumulator. Now you can see the figure of piston type of accumulator over here. In the piston type of accumulator, as the name itself indicates, a piston separates a region of oil and compressed gas. It consists of a cylinder with a freely floating piston with proper seals, the piston serving as a barrier between gas and oil. The gas which occupies the volume of the gas chamber is compressed by the piston as the oil enters the oil chamber through the oil port. The pressure of the oil depends on the compression of the gas and varies with volume of oil in the chamber. The major advantage of piston accumulator is its ability to vary high or low temperature fluids using compatible boring seals, and the main disadvantages being that they are expensive to manufacture and have practical size limitation. Coming to the next type is called as diaphragm accumulator. The diaphragm type of accumulator consists of two metal shells separated by a flexible diaphragm secured in shell. The diaphragm serves as an elastic barrier between the oil and the gas. A shut-off button provided at the base of the diaphragm prevents the damages to the diaphragm by avoiding the diaphragm pressing into the oil port when the gas is being charged. And the oil pumped into the accumulator deforms the diaphragm. As the pressure is increased, the gas gets compressed, its volume decreasing, thus storing of the hydraulic energy. As the pressure drops in the system, additional oil is supplied to it by corresponding amount. And this type of accumulator are compact and a small weight to volume ratio and the best suited for airborne applications. Coming to the last type of separator type of accumulator, that is called as bladder accumulator. A bladder type of accumulator consists of a synthetic polymer rubber, that is nothing but a bladder, placed in a steel shell as shown in the figure you can see. The bladder serves as a barrier between gas and the oil. The bladder is filled with compressed gas, and this type of accumulator responds quickly for receiving or expelling flow of oil. When the oil pressure rises, the bladder contracts, compressing the gas and decreasing its volume, thus storing hydraulic energy. And this results in more space for oil to occupy. When the oil in the accumulator is spent or utilized, its volume reduces, and hence the pressure of the oil in the accumulator. And this allows the bladder to expand, reducing the volume of space for remaining oil in the bladder to occupy, and hence increases its pressure to the initial value. One of the greatest advantage of this type of accumulator is the positive sealing between the gas and the oil chambers. The quick response of the lightweight bladder makes the accumulator suitable for pressure regulating and the pump pulsation, also the shock damping applications. Then coming to the applications of the accumulators, from the application point of view, accumulators can be used as an auxiliary power source, or it could be used as a leakage compensator, and even an emergency power source and a hydraulic shock absorber. So thanks for your patience listening to the session. If you have any sort of doubts, feel free to use the comment section for the further discussion. I will answer all your questions related to the topics covered in this session. Don't forget to like, share, and subscribe. Have a great day. Signing off, Vijay Tavardhan. Bye bye.